Okay, today we're looking at linear inequalities. Inequalities can represent an infinite set of numbers solutions. So when we had linear equations where we had one solution, an inequality has an infinite set of solutions. Okay, linear inequalities are solved in a similar fashion to linear equations, only we have two extra rules to remember. When we multiply or divide both sides of an inequality by a negative number, the inequality sign is reversed or flipped. If we swap the sides of an inequality, then the inequality is reversed flipped. We'll go through some examples that do really show what that is talking about. But first, a quick refresh on inequality symbols. So we have the greater than sign, the less than sign, the greater than or equal to, less than or equal to. Now remembering when you have greater than, if I have x is greater than 10, it means all the numbers greater than 10. It does not include 10. But if I have x is greater than or equal to 10, it means it does include the 10 and all the numbers greater than 10. Let's have a look at some examples. So we're going to show a couple of different inequalities on a number line. So the first one, x is greater than minus 3. Starting with a number line, drawn with a ruler please, we're going to show x is greater than minus 3. But before we start, when we're representing greater than on a number line, we actually do it with an open circle because it does not include minus 3. Now, showing that it is greater than minus 3, we do that with a line going in the correct direction. So we want all the numbers that are greater than minus 3. So when we look at the number line, that's in the right direction because we have minus 2, minus 1, 0. They are all greater than minus 3. So we just draw a line, remembering to put an arrow to show that it is a line. Okay, looking at another example, we have x is less than or equal to 4. So again, starting with the number line, this time it does include 4. So we show that with a closed circle. The way you might be able to remember that greater than or equal to or less than or equal to has a closed circle is that it's similar to x equals 4. When you've plotted that on a number line before, you've always used a closed dot. Okay, looking which way the line goes with the arrow, it's all the numbers less than 4, so we're going to the left-hand side because these numbers are less than 4. Okay, looking at one that has a range of solutions. So I have x is greater than minus 2, but it is less than or equal to 3. So on the number line, plotting the points first, so x is less than or equal to 3, so that is a closed circle. X is greater than minus 2, that's an open circle. Now checking which way our line needs to go. So looking at 3 first, we have x is less than or equal to 3. So we want all the numbers that are less than 3, but they have to be greater than minus 2. So when we're looking at minus 2, all the ones that are greater are going to the right. So we'll draw a line that joins the two dots. That shows a range of solutions. Okay, I'd like you to pause there, get all those examples down, including the blue notes below the examples, please. When you're ready, press play, and we'll solve a couple of equations. Okay, example 2. Find the solution set for the following inequalities. X minus 6 is less than 14. We solve this the same way as we solve linear equations. We get the x to the left-hand side by itself. So we do that by adding 6 to both sides in this case, and we end up with x is less than 20. Now checking this, we can check our answer. If we pick a number, both sides of 20. So if I pick a number that is less than 20, this one should work because x is meant to be less than 20. So substituting that in, I have 19 minus 6 is 13. That is less than 14. That one works. That's good. Let's pick a number greater than 20. So I've chosen 21. So 21 minus 6 is 15. That is not less than 14. So that doesn't work. So that shows that we've got the right symbol there. Okay, I'd like you to pause there, get the example down. You don't need to get the let's check our answer part down. That is more of a mental calculation that you do. When you're ready, press play and we'll solve another equation. Okay. B, 5 minus 2x is greater than 3. Again, we get the x on the left-hand side by itself, so we're going to subtract 5 from each side. So we end up with minus 2x is greater than minus 2. Okay, getting rid of that minus 2 here, we divide by minus 2 because remember it's minus 2 times x, opposite is divide. So dividing both sides by minus 2, I end up with minus 2 divided by minus 2 ends up to be 1. So I'll have 1x. And minus 2 divided by minus 2 is 1. Now you'll notice that I've flipped the sign there. Now the reason we've done that is because we have multiplied or divided. In this case we've divided by a negative number. We need to flip that sign. And at the end of the video I'll go into that a bit more depth so you can understand why we do flip it. Okay, checking your answer quickly. So pick a number that's greater than 1 and it shouldn't work. So I've picked x equals 2. So 5 minus 4 is greater than 5 minus 4 is 1. It's not greater than 3. So that one doesn't work. That's good. So let's pick x equals 0. That's less than 1. This one should work. So I have 5 minus 0. That's greater than 3. Okay, that works. That's good. Remember, that's just a mental calculation to do. Okay, I'd like you to pause there. Get the example down, including this little note, please. And when you're ready, press play for the last example. Okay, example, 2t plus 8 is less than or equal to 7t plus 3. So we have pronumerals on both sides. It's the same as what we did when we were doing in linear equations. So get the t on one side. I'm actually going to get the t on the right hand side. You can get it straight away on the left hand side by subtracting 7t from both sides and you'll end up with negative 5t. But for this example I'm actually going to get rid of the 2t's, so I've got the pronumeral on the right hand side. So subtracting 2t, I end up with 8 is less than or equal to 5t plus 3. Let's get rid of the 3 by subtracting to both sides and I end up with 5 is less than or equal to 5t. Okay, getting rid of the 5, divide both sides by 5. So I end up with 1 is less than or equal to t. Now remembering we like to have the t or the pronumeral on the left hand side, so I need to change them round. When we have the equal sign we just quickly swap the numbers, but when we have an inequality we need to remember that we must flip the sign if we change the sides of the inequality. So I end up with t is greater than or equal to 1. Okay, don't forget to quickly check your answer. Let's just do it mentally for this one. So because it's t is greater than or equal to 1, I'm going to pick 1. And that should equal. So if I've got 2 times 1 is 2, plus 8 is 10, 7 times 1, 7 plus 3 is 10. Okay, they equal. That's good. So we know it equals 1. Let's pick a number less than 1, which shouldn't work. So 0. So 2 times 0 is 0, so I have 8. 7 times 0 is 0, so I have 3. So 8 is not less than or equal to 3, so that doesn't work. So that sort of proves our inequality. I'd like you to pause there, get the example down, ensuring you get this little note down as well, please. When you're ready, press play. Okay, just a quick recap. Inequalities can be illustrated using a number line. Use an open circle when showing greater than or less than. That does not include the number. Use a closed circle when showing greater than or equal to or less than or equal to because it does include the number. Okay, that's an important point. Okay, why do we flip the inequality sign? So I'll just quickly do a little thing that might help you understand that if you're having a little bit of difficulty understanding why we flip it. If we pick any two numbers, as long as they're different, I'm picking minus 3 and minus 6. You can pick any numbers, it doesn't matter. Write the two numbers on the same number line. Okay, so I've got minus 6 and minus 3, they're in the correct order. I'm going to pick a negative number. To keep it easy, I'm just going to pick minus 1. Okay. Now we're going to multiply or divide both of the first two numbers by the negative number that we picked, and we're going to show them on a number line. So I'm going to pick multiply because it's easy again. So I'm going to go minus 1 times minus 3 is 3. Minus 1 times minus 6 is 6. And I'm going to plot them in a number line. So I have 3 and 6. Okay. Now on each of those number lines, we're going to decide which inequality symbol belongs between the two numbers. So if I have minus 6, that's less than minus 3. So let's pop our less than in. If I've got 3, that's less than 6, so I'm going to pop that inequality sign. So fixing that up, I have minus 6 is less than minus 3. That's the numbers we started with the start. Then what we did, we multiplied both sides by minus 1. So we're doing the same thing to both sides, so it shouldn't affect anything. It keeps the balance in. So I have 6 is greater than 3. So we can see why we flip the signs. If we left the sign the same way, we would have 6 is less than 3, and we all know that 6 is not less than 3. So if that doesn't convince you, try some different numbers. Try 2 positive numbers, try positive and negative, and just go through the process, and it will work every time. Okay, that's all for today. Just make sure you get all those examples down and the theory in your book. Any questions, make sure you've got them for me in class.